Welcome to qnawire.
Okay, we have a list here of some reactions, and in question A, it asks us to determine which combination of the half-cell reactions leads to the cell reaction with the largest E positive cell potential and calculate that value. So we're looking for the largest positive E cell. Remember the equation for E cell is that E cell is equal to the potential, the standard potential of the reduction reaction minus the standard potential of the oxidation reaction. So we're looking for the largest possible positive value that we can get. And if you kind of play around with the numbers a little bit, you're going to find, so this is my biggest positive value. I would want to take that and subtract off my biggest negative value, right? So it's going to end up being Ag plus and this guy, but it's going to be the oxidation version of that. So the Cr goes to Ag metal and then the Cr2 plus. Oh, sorry, I think that's supposed to be a 3 plus there. So 3 plus. So to balance that out, I would need 3 here to get the charge balanced. So the E cell for that reaction, again, I know this because I'm taking the biggest positive number minus the biggest negative number, and since I'm subtracting, we're going to end up adding. That's going to give us our biggest positive E cell. So that's going to be 0.80 volts minus a negative 0.74 volts, and that's going to be equal to 1.54 volts, and that's the reaction that would give that to you. In question B, it says determine which combination of the half-cell reactions leads to the cell reaction with the smallest positive cell potential and calculate that value. So this was part A. So in part B, we want the smallest but still positive. And so in this case, because I actually have 2 choices, there's a difference here between this guy, there's a difference there of 0.46, but there's also a difference here of 0.46. So it could be either of those. So my 2 possibilities here would be in this first one, I would want to do the reduction. I would want that to be the silver. So that would be the Ag plus on the left minus, plus the oxidation, which in this case would be this guy. So the copper would be, you want to flip that reaction. So it'd be copper goes to Ag plus and Cu2 plus, and a balance out charge. Oh, sorry, that's just Ag, not Ag plus. And to balance out the charge, I would need 2 silvers here. And so that would end up being 0.8 volts minus 0.34 volts, which is equal to 0.46 volts. But I could get that same value over here if I did the 0.23 minus a negative. So this guy would be my reduction. So I'm going to write it as is. So nickel 2 plus. And then this guy would be the oxidation. So I'm going to flip it so that Cr goes to nickel metal and Cr3 plus. And in order to balance that, I have a charge of 2 on this side and 3 on this side. So I'm going to make this 6, a total of 6 plus on each side. So it gives me 3 nickels and 2 chromiums. And again, that's going to be a negative 0.23 volts minus a negative 0.74 volts, which again gives me 0.46 volts. So either of those give you the same value for your E cell potential.